This is my presentation for my benzocaine project. Benzocaine is a local anesthetic commonly used in a range of over-the-counter medicines such as throat lozenges and sores to generally ease the pain and generally ease your life. Generally used in a mixture with pain relief such as paracetamol, ibuprofen, and can be used as almost in combination with anti-inflammatories. The aim of this project was to accomplish a complete biosynthesis of benzocaine to a high purity and yield, meaning that the product was entirely benzocaine, there was no contamination, and that we didn't lose any of the products along the way, so the yield was as close to 100% as possible. We made sure that we were keeping the product pure by, throughout our synthesis, doing NMR and IR, or submitting NMR, and also doing TLC, as TLC quickly shows if the sample is pure or not. In the first step, we added 12.87 grams of sodium dichromate and 30 milliliters of water, plus 5 grams of nitrotoluene, into a 500 ml round bottom flask. Then we slowly added 30 ml of sulfuric acid slowly over the next 30 minutes. We then allowed it to reflux for 90 minutes, setting it up with a heating hot plate, so a mantle, and hooking up to a condenser and allowing it to reflux for 90 minutes. After the 90 minutes had occurred, we cooled it down, allowing it by removing out of the heating apparatus and left it to cool. We then filtered it by gravity filtration. We warmed the crude solution in the water bath and agitated it with 5% sulfuric acid solution. We then filtered it and dissolved it in 5% sodium hydroxide. The filtrate was then acidified with 5% sulfuric acid, and the nitrobenzoic acid would precipitate. Since we wanted to maintain as much product as possible, we filtered it via Buchner filtration, which made sure that the product was dry as much as possible. So we allowed it to be filtered under Buchner filtration for quite a while, probably about an hour. We then performed TLC, NMR, and IR as stated earlier to make sure that our product was nitrobenzoic acid and that it wasn't contaminated. Step 2. Converting nitrobenzoic acid to ethyl-4 nitrobenzoate. This reaction is an esterification process, so we needed to add 400 ml of ethanol as we wanted to add 2 carbons onto the oxygen. And so we added 5 grams of nitrobenzoic acid from earlier, with 0.1 ml of sulfuric acid to act as a catalyst. We added them into a 500 ml round bottom flask again, and refluxed it for 90 minutes, in the same style mentioned earlier. It could be noted that a smaller round bottom flask could be used, but we already had the apparatus set up for 500 ml. After this, we performed liquid-liquid extraction with 100 ml of diethyl ether and 100 ml of pure water. However, we did allow it to cool again first. We returned the inorganic into the pear-shaped flask and repeated twice, and made sure to keep the organic separately. We then added sodium carbonate to the organic and performed another liquid-liquid extraction. We then added magnesium sulfate to the organic layer to remove water. We then filtered via gravity filtration to remove magnesium sulfate. We then rotary evaporated to remove the organic solvent. Step 3. Ethyl-4 nitrobenzoate to ethyl-4 aminobenzoate. So we wanted to convert the NO2 to an NH2. So we had 10 grams of ethyl-4 nitrobenzoate, as there was a couple issues presented in the second step, mainly due to the inability to get all of the product out of round bottom flask from the rotary evaporation, so we just got some pure sample and made up to 10 grams because that was advised by the lab techs. So we had 10 grams of ethyl for nitrobenzoate, and we added it to 500 milligrams of palladium and carbon catalyst. We didn't use any more as there was a risk of excessively rapid reaction. The pressure changes were deemed dangerous. And we had concentrated sulfuric acid to provide the hydrogens. We then refluxed this for 120 minutes. We then used Buchner filter using sea light to remove the palladium and carbon catalyst and ensured the catalyst was disposed of as soon as possible. As it was stated, the catalyst was flammable and dry, so we had to ensure it was disposed of carefully. As stated earlier, we did TLC, NMR, and IR spectroscopy throughout every stage to ensure that the product was what we intended and that it was pure, which we made sure of every time. And in step 2, as I said earlier, we lost yield due to the round bottom flask. And so we had to add further nitrobenzoate so that we could keep step 3 going. And it made the numbers rounder, which we felt easier would be for the calculation and then our final yield. In conclusion, our synthesis of benzocaine was successful, however we faced a minor loss in yield at the end of stage 2 as stated earlier, which could probably be improved on by improving the carefulness of the liquid-liquid extraction, as that further led to a minor loss in yield. However, it was mainly due to the round bottom flask error, because it's almost impossible to get all that crystal out of a round bottom flask. If you can see the image, it's not valid to scrape at all. Thank you for listening.